people?
So I do math. My area is called topology. The type of topology that I do is called homotopy theory. I study high-dimensional shapes. A homotopy type is a whole collection of spaces that are all equivalent to each other.
How did you decide that you want to do math?
I didn't always know. And in fact, I distinctly remember in grade school being in remedial math class because I was a lot slower at arithmetic than the other kids. Yeah, I was just like really not good at it. And in college, I took a calculus class that sort of changed everything that I thought about math. I found that the more math classes I took, I became more interested in math and I became less interested in physics. Somebody told me that there was such a thing as graduate school. I like doing math. Maybe I should keep doing math. Somebody told me that you could just keep on doing math. So that's what I'm doing.
Just keep going.
Yeah.
That's cool.
I think it's very creative and I like that it has a bit more certainty to it in some way. I really like solving problems. I like solving all kinds of problems. And math, gives you lots of interesting problems to think about and sometimes solve.
I like how you say sometimes.
Definitely not all the time. So I was thinking about that, and I was thinking about something I read by Bill Thurston. Mathematics is what mathematicians do. Mathematicians are people that explain things. And I like that he sort of puts that human connection in there.
I saw like on your CV that you teach a lot of classes for teachers. That must be really interesting, teaching teachers. Does somebody teach you how to teach the teachers?
Yes, that's right.
It's just another interesting chain, recursive.
So
what is that like?
It's wild. It's really different from teaching the kinds of classes that I taught as a graduate student. Have I experienced fear? Yes. So times when I've realized that something I thought was right is in fact not right, that's a terrible feeling. It's, not only do you not know what to do, you don't even know what to do in order to figure out what to do. I think my own way to get out of it is just to kind of bring things back to the simplest possible case that I can sort of try to understand. You have to solve the problems you can solve in order to sort of work up to the problems that you can't solve.
What makes math beautiful?
So I knew this was coming because I saw it in your other interviews. In particular in mathematics, things that somehow capture different ideas, sort of wide-ranging ideas, in a relatively concise way. So Euler's formula that connects the complex exponential with the trig function. I think it's fair to say that that is objectively beautiful. It connects different ideas. My favorite example of this is actually place value arithmetic. So there's a theory there about, representing numbers in base 10. And that theory is important to know, but I don't think that theory is the mathematics. And then there's a procedure, say, for the way you multiply. And that's not the mathematics either. Then there's the explanation for why that procedure works. Kind of seeing that connection, that's the mathematics. And of course, you can't know the mathematics without knowing both of those things.
You had mentioned being a bit slower in math or early on, like maybe just arithmetic. How do you feel about it now? Are you pretty good at it? Or do you always take out your calculator? Do you do it in your head or what?
So I always tell my students I'm just no good with numbers. I think I'm better now than I used to be. Pretty good at adding, actually.
Yeah?
I mean, when I say pretty good, I mean I can do all the single-digit sums.
Nice. How about subtraction?
I'm actually pretty good at subtraction. I think the reason that subtraction seems harder is you have to be able to recognize more forms, sort of a minus b for more values of a and b. The idea is to sort of think of numbers in triples. 5, 8, and 13 is actually my favorite. I just love it. And then later I learned that 5, 8, and 13 are Fibonacci numbers and they appear in the Fibonacci sequence.